So hi everybody. So in today's video we would be looking at storage part in system design. Now whenever you design a system, so it's very important at that whole moment that you deep dive into the storage part. But recently we have seen that there are a lot of optimization options that have come in storage part of system design, and we would be looking all of them in detail when we deep dive into examples part. But in today's video we would be looking at what is exactly like happening in the storage part, how important that is, like read and write operations, the three types, the disk, persistence and memory. So yeah, so in the realm of system design, storage is a critical part. As I told you, it is responsible for reading, writing, updating and a lot of things. So it's responsible for keeping data available and accessible over time, even right now, like milliseconds or years. So as systems evolve and grow, the storage solution must be efficient and scalable and reliable. You can't expect a system which has been designed right now and has a storage of, let's say, 300 GB to be feasible for you after 1 year of your service growth. So there are primary storage, RAM, ROM, we have talked about it. Then we have secondary storage, that is HDD. The usage of HDD, the hard disk drive, is commonly used for long-term storage in both consumer devices and enterprise. So let's look at databases. So the database has two programs, the two main core programs. I will use the pen now, and let's move aside. The two more important part, the two part is record and query. These are the two most important part of a database. Either in general they are themselves servers and they are long-lived and interact with the rest of your application, because think something like that. When we were talking about client and server model, so when the client was requesting through server, this server can itself be a database. So it interacts with the rest of your application through network calls and with protocols on top of TCP or even HTTP, as we talked in the client and server architecture. But some database only keep records in memories, and the users of such databases are aware of the fact that those records may be lost forever if the machine dies. That is the reason we create replicas. Suppose this is a database. Now for this particular database, I can create a replica of this database, D1. I can even create one more replica of this database, that is D2. And just like this, we can create multiple replicas. We can even, use techniques like sharding. Now, what sharding does, we will talk about sharding in detail in the upcoming videos, but just giving you guys a glimpse. We can divide the whole database into smaller database, like database 1 has been divided into D3, D2 and D1. Now, these databases would specifically store information according to the schema that we have defined, that okay, this one should store IDs, this one should store something like contact, and the middle one can store name, something like that. Now moving back to the disk part. So usually this is referred to, as I told you, HDD, hard disk drive, or SSD, the solid state drive, and the data written to disk will remain persistent through power failures and general machine crashes. Just think something like this, that even if the data that has been written to the disk will remain persist through the power failures and general machine crashes, because it is written through a solid state drive method. Now SSD is faster than HDD, we have to consider that, but also far more expensive from a financial point of view, obviously, because when you go for buying SSD, you will see that the prices of SSD are much more higher than HDD. So you need to know only this much about disk right now. When it comes to memory, short for RAM, the random access memory. Let's go to the pen part again and discuss about it. So yeah, so when we talk about RAM stands for random access memory. The data stored in memory will be lost when the process that has been written, that the data dies. So it's simple as that. It is used for temporary storing data that's actively being worked on, and it's a very fast storage tier, because but the disadvantage is that data is lost when the power is turned off. you can think it is of example the processes that you have been doing, and when you close the system, the information of those processes is lost. So that's the best way of thinking of that. Now comes the persistent part. What is a persistent storage? So let's discuss about it. So you can think like that. It usually refers to a disk, but in general, it is any form of storage that persists if the process in charge of the managing it dies. Now, we have talked about different storage option before this. Like we talked about memory, we talked about disk, but persistent storage is, I think, one of the most important one, because in context of computing, it refers to the storage solution where data remains intact even if the system is turned off. Suppose this is my system. I had some XYZ operation here, XYZ data here, and my system is turned off. But even after that, it contracts with the volatile storage like RAM, where data is lost upon shutting off, but this will remain with me. Persistent storage is crucial for retaining user data, application data, system logs, configuration, and a lot of things. So there are a lot of persistent storage we talked about. So one was HDD. Now the other was SSD. Then we have we have optical drives. Then we have tape storages. Then we have NAS. If you guys know about NAS. So NAS stands for network attached storage. So these are dedicated drives connected to a network that provide file-based data storage to other network devices. Then you have SAN. SAN stands for storage area network. Then you have these are very obvious: USB drives, SD cards, and a lot of things. So the characteristics of persistent storage are like durability, it has capacity, performance, the measured by IOPS, and throughput. The latency, the time it takes to retrieve or store a piece of data is very good. The cost, we were talking about financial part, not just the initial purchase price of persistent storage things, but also long-term costs like power, cooling, and maintenance are one of the characteristics of persistent storage. So yeah, that was it, I think, for this video. In the next video, we would be looking at important things that I told you, like we will look at latency, throughput, and why, storage is important when it comes to latency and throughput. Because, reading 1 MB from this read operation, reading 1 MB would take different than reading 1 MB from RAM, and reading this same 1 MB from SSD is going to take different time. So we will choose a storage system accordingly. So yes, that was it from my side. I hope you like this video when it comes to the storage part, and you understood what exactly I'm trying to tell, the importance of storage in system design. So thank you and have a nice day.